So this is a sort of a new avenue. It's largely perspective, but was motivated by a recent conversation I happened to have circa the beginning of the vaccine rollout with a bioethicist friend of mine. And well, I don't want to give too much away, but the context here is that a lot of the explanations that were invoked for what was going on, what was going wrong, why we were not adequately distributing vaccines, seem to me to overlook some subtle questions of what values we were trying to adhere to in the actions that we took, which led me to other connections with how these sorts of value judgments are made in the various steps of mathematical modeling. So this is a fairly philosophical talk, not really any numbers, mostly just ethical considerations and a couple of toy models that show how they can play out in the day-to-day business of how we do our work in mathematical modeling. So I hope found them interesting. Hopefully you do as well. But I'll get started. So just for a little bit of historical context, right? This is going back to the beginning of last month. The Advisory Committee on Immunization Practices, which advises the CDC and the federal government, made interim recommendations rather for how to allocate the vaccines. This was slightly before it actually had any vaccines with which to advise, but the Pfizer and Moderna vaccines were approved a little bit later in the month. And the crux of their recommendation was to create tiers, essentially priorities that would be entitled to vaccine access in some sort of preferential way. So in the initial recommendation, they defined what they called phase 1A, a top priority, consisting of healthcare personnel and long-term care facility residents, nursing home residents who had been disproportionately impacted. In the middle of the month, they then actually approve these vaccines and they start to ship. And very shortly after they start to ship, you can see, a little more than a week after the Pfizer vaccine is approved and starts to ship, they update these recommendations in the face of, but both to define what were supposed to be the initial phases, but also in the face of what started to be some fairly severe pushback in terms of the limitations of these priority schemes. So they introduced these additional components of phase 1 for older ages and essential workers, and then for somewhat less old ages and somewhat less essential workers. And people were largely kind of furious about how this all transpired. There were, all sorts of stories in the media of people who were responsible for administering or delivering vaccines were essentially idled because they were trying to adhere to very rigid interpretations of the priority scheme. In response to that outrage, states start to sort of just do their own thing and ignore the federal guidance. California, on January 7th, loosens its eligibility requirements. Shortly thereafter, actually the next day, Stephen Hahn, the commissioner of the FDA, essentially acknowledged this problem and said states should loosen their eligibility requirements because they were being interpreted too strictly. But even after that, it remained a very thorny problem, especially in New York, my home state, where I tend to follow the news, which was in the peculiar position that a hospital could be fined for a delay. If they didn't administer a vaccine within a week of receiving it, they could be fined a substantial amount of money. But they could also be fined if, in the interest of distributing that vaccine quickly, say within the mandated 1 week time frame, they breach any of the fairly rigid eligibility protocols set up by this tier system. So, how should we make sense of this sort of outcome? Well, a lot of it was non-technical and, well, might be interest of people here as citizens, but not necessarily as mathematical modelers, right? People doing the distribution were incompetent. There wasn't enough leadership. On the right, it was too much government meddling, and on the left, it was too little government oversight to prevent misallocation of vaccines, say to wealthy hospital board members, which of course is something that did happen. But I think there's a more nuanced answer here, which is there was an inherent ethical contradiction in what was trying to be achieved with these guidelines and with the rollout. And it's not really all that hidden. If you look at the ACIP ethics guidance, on the first page, two of their primary sections that set the stage for the sort of ethical framework they're trying to promote. One is to maximize benefits and minimize harms, which they elaborate a little bit to say is the allocation of the COVID-19 vaccine should maximize the benefits of vaccination to both individual recipients and the overall population. And the second is to promote justice. This is rooted in the idea of fairness, that allocation of the vaccine should ensure that people are not differentially vaccinated based on some element of their status or identity. It is, I think, somewhat serendipitous. I'm giving this talk immediately after the last one, which also dealt with questions of fairness. The conflict between these things is, well, it's sort of similar to the accuracy fairness discussion we just heard. Is that if you want to maximize benefits, broadly speaking, so you want to allocate, sort of looking at society at large, it doesn't guarantee that sub-allocations to subpopulations adequately adhere to notions of justice. And in fact, there's even another conflict buried in these, just in the first clause alone, which is to maximize the benefits of vaccination to both individual recipients and the overall population may pose a contradiction in that an individual recipient at high risk might or might not play a large part of a future transmission chain. So if your goal is to prevent harm to high-risk individuals, you wouldn't necessarily pursue the same policy as if you were attempting to control the epidemic for the good of the entire nation or the entire world. So I'm going to return to that a little bit when I sort of summarize some of the bioethical pillars that this is built on. But first I said, well, what did this problem look like from a modeling perspective? And to the extent that I understood this in conversations with other people who work in this sort of modeling space, we conceive of models this way, right? Define a model, by which we mean some sort of mapping that takes observable features of a system, some sort of data, or other characteristic, and goes from one place to another, right? An initial state to a final state, or the raw data onto parameter estimates or statistics on that data. And then if we want to use the model for something, we would define a target function, right? This is where we implement the values in our preferences, avoid excess deaths, avoid excess years of life lost, which would be a somewhat different metric, whatever you want it to be. And then you want to use your model to optimize outcome with respect to that target function. So as I say here, there is kind of a catch, but let's try to follow this through and see where it leads. First, we have to think about what is the target, and in the context of epidemiology, this is not exclusively governed by, but is strongly informed by medical practice and the bioethical considerations that go into medical practice. And these are fairly well established and quite explicit. I mean, this is part of the training that doctors receive, and it's enforced by the professional organizations that oversee their work. But the principles are autonomy, non-maleficence, beneficence, and justice. Autonomy is largely rooted in Kant and essentially just says you shouldn't make people do things they don't want to do. Summarizing, of course. Non-maleficence is that you essentially should not do harm or not do anything willfully, not give or withhold treatment that you think will cause harm to your patient. Beneficence means trying to ensure a good outcome, and in some sense is the closest thing we have to a utility principle or a consequentialist ethic. And it's sort of similar to the notion of efficiency in the last talk. And it's something that you want things to work well, just for their own sake. And then justice, of course, has almost exactly the same meaning as the fairness of the last talk, although there are multiple frameworks of justice, and many of them due to roles, that you should have a regard for the possibility that you could be any member of the society receiving the action, a society receiving the benefit, and you should make your decision about allocations or about decisions on the assumption that you don't know which member you would be, right? This is what Rawls called the original position. Modelers have a strong bias towards consequentialist ethic, which is, at least in this framework, is sort of the beneficence idea. Just try to optimize good, the total amount of good you do. But it's really important to realize that these are all significant, and they are all widely present in our custom and in our laws and in our policies, blood transfusions are a great example where a patient could come into a hospital in dire need of a blood transfusion as diagnosed by a doctor who has professional expertise, scientific training in making that determination. But patients have the right to refuse that transfusion, and this often happens, say, with Jehovah's Witnesses who are religiously opposed on the basis of autonomy. I mean, we grant autonomy precedence over utility some of the time, but it's not an unrestricted right. For instance, while you can refuse a blood transfusion for yourself, you cannot refuse one for your child. Right? The right to take on harm to yourself does not necessarily extend to a right to potentially inflict harm on others. There's an important distinction, I think, in the vaccine distribution, which I'm going to return to in a little bit. So now what about the model? Well, here we have another set of problems, which is that there are a lot of possible models you could use to forecast an epidemic and thus to forecast the consequences of intervention actions like vaccine distribution taken to address that epidemic. And we have compartment dynamics, which are the canonical SEIR type models of epidemiology. We have network dynamics. We have non-dynamical system theories, like a dynamic causal modeling, which Carl Friston pushes somewhat heavily. And we have some way of trying to choose, either from those model categories or from a given model within a category, how do we pick out the one we actually want to use? And we have an abstract notion that we should pick a model that is skillful, which we usually think of as being a value-independent consideration. And it can mean any number of things. It can be robustness to measurement error, robustness to parameter variation or parameter fine-tuning. It can be that the model is specific in its projections. It can be that it is accurate in its projections, any number of these things. So we want to put these things together to somehow make sense of the COVID response. And here I'm going to briefly turn to something very different, and for which I should certainly acknowledge Simon Levin, with whom I work, as having come up with this case study from almost 30 years ago, more than 30 years ago, 84, in which there was a fisheries catch model comparison, essentially comparing one biomass and yearly catch model of fish that did not resolve the ages of the fish population, and a newer one that did. Essentially, was a more fine-scaled model to describe the underlying population of fish from which one was pulling the catch. And when the dynamics were simulated, having trained this on the historical data that was available for the fishery in question, the lumped model, right, that just had the catch data and aggregate biomass, outperformed this age-structured model, even when you controlled for the differential number of free parameters. And even when it was a simulated data set where it was the age-structured model that is actually producing the data. The lumped model did a better job of forward prediction for catch and for catch policies than the model that was actually generating the data. It's not impossible to see why this would be. If you're fitting a more complicated model, the way in which the data is assimilated to fit specific parameters could be sensitive to data uncertainty in a way that is more perverse or more destructive from the point of view of policy management than the simpler model, which just might be more robust to the fitting procedure. And in this case, it's not a huge philosophical problem because the target that was wanted, having the best catch in the long-term sense of extracting food from the fishery was clear. But if the target isn't clear, then this really becomes a much bigger, or this possibility, I guess, becomes a much bigger problem. We now imagine the same issue projected onto the vaccine distribution situation. We imagine a lumped model of population dynamics and some sort of cohort structured model, which could be age structured or occupation structured, geography structured, however you want it to be. Each is fit to data. You simulate data for both models, and you try to manage based on one model or the other, looking forward in time to the simulated data. If it followed the example of fisheries, I'm not saying that it necessarily would, just pointing out that it could, you might be in a position where the simpler model, the lumped model, is better in some sense. say that it minimizes deaths relative to the other model. But is it better? Or should we regard this as being better? Should we regard it as being more skillful? I don't think the issue is that the model is good or bad. The issue is that there is a type of cost that is indeterminate in one model versus the other. And that's actually how should we be looking at these things. Not can we sort of tune the models in an ostensibly neutral way to improve their performance, but understanding that the choices we make in the modeling process, not just the value explicit ones, like when we choose a target function, but even the model constructive steps, in fact, predispose us towards certain value structures. So now I'm going to give an explicit example of this and then take questions, since I know this is probably a somewhat different idea than is common in this area. Suppose you had an epidemic that's well described by SIR, which is to say it follows this simple set of differential equations, only 3 of which are actually independent. But essentially you have a rate of change of the susceptible population based on the interaction between susceptibles and infectious people and some parameter. People that leave the susceptible pool enter the infected pool, so it's that same quantity appearing again, and they leave the infected pool either by way of recovery, which is gamma R, or death, gamma D, which then leads to, accumulation rates for those 2 state variables. And when I say that it's well described by SIR, again, this just means that it can yield an arbitrarily good representation of the data, right? This is a hypothetical. I'm not positing that this is a perfect representation of any actual data series. If you now consider some sort of intervention, I think the simplest example is a mask mandate, where you can have a mask filtering exhaled particles and a mask filtering inhaled particles, which attenuate the particles inhaled by AI and AT respectively, attenuating the infection risk when you inhale, attenuating the transmission risk when you exhale. But you don't know their values. You put them into this equation. The equation would look structurally identical, except you have a new beta that was the original beta times the product of these 2 variables. And again, for the sake of argument, suppose that you also get as good a fit as you could possibly want. Would you regard this model as correct in the sense that, this is now a good representation, a good positive representation of the system on which some normative objective, like something drawn from that list of bioethical principles, can be imposed? If you happen to define consequence as total deaths, as functionally, we've been doing in practice, then this is a perfect model, right? It perfectly predicts the data. You have good confidence that it will predict the future, and it tells you exactly the quantity that you need to measure your cost function according to your chosen ethical consideration. But AI and AT are completely indistinguishable in this model. So you can, no matter how well you fit it, no matter how much you refined it, or otherwise satisfied yourself that the model worked in the usual sense that we mean that models fit to data, you could never resolve autonomy harms, because the autonomy cost, going back to the blood transfusion example, of essentially compelling someone to do something that's only good for them versus compelling someone to do something that's good for the public is different, right? Under that value scheme, these are differential harms, and they are immeasurable, or sort of irresolvable under this model framework. Again, not the model framework that asserts this is the target function, but even just the predictive, descriptive model framework that says what's going on. And this is a sort of troubling realization, because it leads to the conclusion that there's this neutral step of model development where we don't think of ourselves as imposing values, but often we are, because we preclude the use of that model under different value frameworks. And this means you can have a structural default that arises just from the model construction that leads to a value default. And this is, I think, ideologically something we should be concerned with, but it's also something that I think has practical precedent. And you see it in economics, say, vis-a-vis environmentalism all the time. If you only quantify accounting costs and you don't quantify things like environmental harms, you create a default situation where now you essentially just write down the value of environmental harms because they aren't classified in your modeling scheme, even if the model scheme is nominally neutral. So this was the idea I was thinking about in terms of the last month of COVID vaccination news. And thank you for your time, and let me know if you have any questions.
Thank you, Ben. Great talk.